Did you ever play with roly-polies or pill bugs as a kid and watch them curl up when provoked? Or have you ever seen footage of an armadillo rolling up into a ball? These bugs and animals weren't the first creatures to use that as a defense mechanism. Nearly 500 million years ago, some trilobites were using this same tactic when protecting themselves from predators or other environmental hazards. To give you a better understanding of these creatures, I'm going to explain what scientists have discovered about them and how they have made these discoveries. After gathering information from several credible sources, I'm equipped to give you accurate information regarding trilobites. Trilobites rank among the most successful creatures to have ever lived on Earth. In this presentation, I will give you an overview of some general information regarding trilobites. I will discuss how certain anatomical features, which have led scientists to draw conclusions about trilobites' lives, and finally I will talk about the obsession with trilobite fossils throughout the history of mankind and today. Now I'm going to provide some general information regarding trilobites. Trilobites get their name from their anatomy. They are laterally separated into three sections: two pleural lobes on the right and the left side of their body, and one axial lobe running down the middle. Trilobites thrived for almost 300 million years. Their existence stretches from the Cambrian explosion until the Permian mass extinction. Trilobite fossils have been well preserved in layers of rock spanning this time range, so scientists have a clear idea of the time frame trilobites survived in. Throughout the course of their existence, trilobites became incredibly diverse. Scientists have currently identified over 20,000 different species of trilobites, and it is likely that more species have yet to be found. Because of the abundance of trilobites that lived throughout the Cambrian period, this time is often referred to as the Age of Trilobites. The abundance of trilobites is evident as their fossils are very common in rocks originating from the Cambrian period. Being so abundant, trilobites also populated most of the marine environment of the time. Scientists have found trilobite fossils on every continent, showing that they lived practically throughout the entire ocean. Since trilobite fossils contain no remnants of DNA, scientists have studied them by analyzing their anatomical structures. These preserved structures can tell us a vast amount of information regarding the creatures, such as the environments in which they lived, the food they ate, and the way they behaved, among other things. I'm going to start by talking about some common anatomical structures among all trilobite species. As I mentioned before, trilobites' bodies are divided laterally into three sections: the pleural lobes on the right and left, and the axial lobe which runs down the middle. The trilobites can also be divided, however, into three sections running the width of their body, which are also labeled on this picture. These segments are the pygidium, which is the tail, the thorax, which is the middle of the body, and the cephalon, which is the head. Apart from their symmetry, all trilobites donned hard shells. These shells are the anatomical structures which are most often preserved. Before the rise of modern technology, scientists often had difficulty uncovering trilobite fossils without damaging them. Now, however, scientists can use more precise methods of drilling, along with the assistance of air-abrasive machines that remove sediment surrounding the fossils. These technological advancements enable scientists to gather more detailed specimens, which in turn leads to more accurate predictions regarding the lives of trilobites. Additionally, trilobite fossils have been discovered that reveal pairs of antennae and numerous jointed limbs underneath the shell. These structures allowed the trilobites to navigate their environments. While all trilobites shared a few common attributes, there was a huge amount of variation that distinguished the over 20,000 species. The most famous and important anatomical structure attributed to trilobites are their eyes. Yet not all trilobites had eyes. Scientists have discovered many trilobite fossils with no evidence of eyes, so some were seemingly blind. Those who did have eyes, however, showed scientists an amazing evolutionary adaptation. Trilobites' eyes were made up of calcite crystals, making them hard. They are often fossilized with the shells. Trilobites' eyes are the earliest complex eyes that scientists have discovered. Scientists theorize that the adaptation of eyes helped trilobites avoid predators, seek out food, and maneuver their environment, as animals use their vision for today. Another variation among trilobites is body shape. Scientists can use the body shapes of different species of trilobites to hypothesize the environments in which they lived. Dr. Richard Forte, a British paleontologist, showed the BBC how scientists can use the body shapes of trilobites to draw such conclusions. For his experiment, Dr. Forte put trilobites of different body shapes into a tank filled with water. He then released dye while a jet of water blew across the trilobite fossils. Trilobites with bulkier bodies were not well streamlined, so scientists determined that these trilobites most likely lived on the seafloors and moved through the mud and sand. Trilobites whose bodies were smoother and thinner were much more streamlined. These trilobites may have swam through the water and may not have been confined to the sea floor. Outside of Dr. Forte's experiment, scientists have also hypothesized that small trilobites, some smaller than 3 millimeters, floated near the ocean surface like plankton. Scientists can also determine the likely diets of trilobites by studying their mouths. Most trilobite fossils reveal that trilobites did not have large mandibles. This indicates that they likely were not predatory creatures and ate only softer foods. A small number of trilobites, however, had long spines near their mouths. These spines likely were used for hunting and cutting up larger pieces of food. As I mentioned in the introduction, some trilobites rolled up into balls to protect themselves when they were in danger. The trilobites that did roll up had flexible lobes which ran the width of their body. Scientists can tell that trilobites exhibited this behavior because they have found fossils in many different stages of curling. Additionally, scientists believe that the behavior was in defense by observing organisms that currently roll up for protection and by scanning rock formations where there are signs of natural disasters. In these rock layers, scientists often find trilobites either partially or fully curled, signifying that they tried to protect themselves from the natural disaster. Abnormal body structures have also been observed on several species of trilobites, from large spikes protruding from their backs to horns and even trident-like structures poking out of the tops of their heads. Trilobites can be found with a number of fairly outlandish body structures. Many scientists believe these abnormalities were used as defenses against predators. Dr. Robert J. Knoll, an entomologist and ecologist at Queen Mary University in London, told the New York Times that these striking features may not have been used for protection, but for attracting mates. Comparing them to a peacock's feathers, Dr. Knoll said that such exotic structures are typically intended for sexual selection in modern-day organisms, and the evolutionary value of similar characteristics should not be wildly different in extinct organisms. After discussing some of the many variations among trilobite species, I bet you can understand why humans might find such fossils intriguing. You may be surprised, however, to learn that collection of these fossils may have begun long ago. Trilobite collection may have started as early as 50,000 years ago. In Europe, human burial grounds from that time have been uncovered with trilobite fossils found in people's personal possessions. European scientists of the 17th century referred to them as frozen locusts when making references to them. Some Native American tribes may have viewed trilobite fossils as religious tokens. Trilobite fossils have been found in Native American burial grounds made into jewelry which may have been used in religious rituals. There are even reports of President Thomas Jefferson collecting trilobite fossils. Currently, collectors search for trilobite fossils in outcroppings of rock and even purchase them off the internet. I found one for sale that had an asking price of nearly $10,000. It was said to be museum quality, so I guess you get what you're paying for. Collectors may well avoid Kansas when in search of trilobite fossils, since the oldest rocks that reach Kansas's surface come from the late Paleozoic era, in which trilobite species were rapidly decreasing in prevalence. Samples that have been collected in Kansas, though, show what some of the last trilobites looked like before the creatures went entirely extinct. Trilobites were some of the longest surviving creatures in Earth's known history. In this presentation, I gave you some general information regarding trilobites. I explained how scientists used the anatomical features of trilobites to determine information about how these creatures lived, and I discussed the popularity of these fossils in today's culture as well as throughout human history. Trilobites are some of the most popular and well-known fossils. After listening to my presentation, I hope you can see why that is the case. I, for one, gained a newfound appreciation of these creatures through the research I conducted. If you're interested in learning more about trilobites, yes, there is more to learn, you can check out the University of Kansas's Natural History Museum in Dyke Hall, which has several well-preserved samples that I have seen on numerous occasions. That's all I have, and I hope you enjoyed my presentation. Thank you.